The Pythagorean Theorem. Before we start with the Pythagorean Theorem, we need to talk a little bit about radicals. Most of the time when you see something like this on the screen, we always call it the square root sign. In actuality, it's called the radical sign. So this is called simplifying radicals. The square root of 25 would be 5. That one you know. The square root of 50 is a little different though. We can break that down. We can break that down into the square root of 25 times the square root of 2. The square root of 25 we know is 5, and the square root of 2 we just would leave as the square root of 2. That would be called simplified. How about the square root of 27? We could break that down into the square root of 9 times the square root of 3. The square root of 9 is 3, so we have 3 root 3 as a simplified radical. Here are 4 more of them for you to try. Take a moment, pause the recording, and make sure that you know how to get these. Hopefully you tried those, and the answers are now on the screen. Square root of 28 breaks down to 64 and 2, which is 8 root 2. 289 has a square root, it is 17. 150 can break down into 25 and 6, which would be 5 root 6. And 243 can break down to 81 and 3, which is 9 root 3. This will be something that we're going to use quite a bit when we talk about the Pythagorean Theorem. The Pythagorean Theorem, as hopefully you can recall from your studies in algebra, is a squared plus b squared equals c squared. The key and most important part of this formula is that the c will always be located opposite the right angle. If we draw an angle away from the right angle, or excuse me, draw an arrow away from the right angle, we will be pointing at the hypotenuse, which will always be the c. Now this formula can be written in other forms. We could write c squared minus b squared, which equals a squared. Or we could write c squared minus a squared equals b squared. All of those actually are the Pythagorean Theorem. They're just written in a little bit different form. Let's try one. The first thing we need to do is identify what's going to be our a, b, and c. I will use the bottom leg of our right triangle and call that a. The side leg I'll call b, and the 13 therefore has to be my c because it's the hypotenuse. I set it up as a squared plus b squared equals c squared. Most of you, once you get to this point, will not have a problem. The problem comes in making sure that you put the right numbers in for the right letters. X squared equals 25, so x equals 5. And there we have it. This triangle would be a 5, 12, and 13 for a hypotenuse. Here's another one. This time it says find the exact value and the approximate value of y. First thing we need to do here is identify what is y. Is it a leg or is it the hypotenuse? Remember, opposite the right angle is always the hypotenuse. We have 13 squared plus 15 squared equals y squared. 169 plus 225 equals y squared. So we have a pretty good start here of the problem. Now we need to figure out what it means when it says the exact answer and the approximate answer. Right now we have 394 equals y squared. The approximate answer would be to get out your calculator and hit the square root of 394. We'll round this to 2 decimal places and see that the approximate answer is going to be 19.85. Now the exact answer, we need to break down the square root of 394. And if you check your perfect squares, you're going to see that there actually isn't a way to break down 394. So our exact answer will be the square root of 394. We have not rounded, we have not dropped off any decimal places, we have simply written it out as a square root of 394. That's going to be really, really useful as we further study geometry as we get to the end of the book in chapters 10 through 14. Here's a question: do the following lengths make a right triangle? What you need to realize here is we know one important thing of a right triangle, and that is the longest leg, in this case 35, has to be the hypotenuse. The hypotenuse is always the longest leg. So we will do 21 squared plus 28 squared equals 35 squared. Now we need to check this all out to see if indeed it works. 21 squared is 441. 28 squared is 784. Equals to 35 squared, which is 1,225. By adding 441 and 784, we get 1225 equals 1225. Since we get to a point where we have a true statement where the a and b squared do equal the c squared, we would say yes, this does make a right triangle. So if asked, do these three lengths make a right triangle? If so, explain why. This would be an explanation, putting them into the Pythagorean theorem and showing that they work. Here's another example. Do the following side lengths make a right triangle? This is a little bit trickier because they have radicals in it. What you might need to do is actually enter these in on your calculator to see which number is biggest. Once you do that, you're going to see that the square root of 24 is the largest. So we have 2 square root of 2 squared plus 4 squared equals the square root of 24 squared. Now, as we do this, we're going to be learning a little something new here. We're going to square these parts individually for the first one. We have 2 squared, which is 4. Now, the square root of 2 squared looks like this. The square root of 2 squared. The square sign and the square root actually cancel each other out, and we're just left with a 2. That means that this first one becomes 4 times 2 plus 4 squared, which is 16. And again, just like we had before, the square root sign and the square cancel each other out, and we're left with 24. Now 4 times 2 is 8 plus 16 equals 24. Once again, we do have a right triangle because the a squared b squared equals the c squared. If you have an issue with these, make sure to talk to me. I can help you out, and I can also show you how your calculators can calculate these for you. A Pythagorean triple is 3 whole numbers. Remember what whole numbers are. They are our counting numbers starting 1, 2, 3, 4. Actually starts at 0, but we won't have 0 for these because we're not talking about sides. Or excuse me, sides can't be 0. 3 whole numbers that satisfy a squared plus b squared equals c squared. So in other words, there are 3 whole numbers that work in the Pythagorean theorem. Example, 3, 4, 5. Can you find examples of the Pythagorean triples? There are actually lots and lots and lots of examples. 3, 4, 5, 6, 8, 10, 12, 16, 25, and onward and onward. The key is they must be whole numbers. No decimals, no fractions, none of them will work. They have to be whole numbers. Our last question for today's notes is to find the value of x. You'll notice here x is way down in the bottom here. In order to find that, we're going to need to find out other information about these triangles. On this picture, it is a rectangle, And we know that because the two right angles that are already there forces this to be a right angle here and a right angle here. So the triangle that I'm shading in blue right now is indeed a right triangle. We can't just call things right triangles. We need to know that they're right triangles. And because of the information on that picture, we know that that triangle has to be a right triangle. The next thing we're going to have to realize is that this 68 on the right side can be moved over here to the left side, 68 feet. Then also, I traced this line here is 68 feet, and this line up here is 82 feet. That means that the little piece we have left over right here is 14. We now have enough information that we can actually calculate out part of our triangle. We can do 14 squared plus 68 squared equals c squared. And notice the c will be right there. That's my hypotenuse. 14 squared is 196. 68 squared is 4624. And we're trying to find c squared. When we add them together, we get 4820 equals c squared. Now, to get our answer, we simply just square root. So c equals the square root of 4820. Let's just leave that exactly as it is, because we don't need the decimal. That actually becomes a little bit more challenging. If we now look at our picture, we now want to use the red triangle. We're going to use c squared, which is 4820, plus x squared equals 76 squared. When we square a square root, we're just left with 4820 plus x squared equals 76 squared. Now, all we need to do is minus the 4820, and we have our answer. X squared equals 956. So x equals the square root of 956. Now we can see that we could either from there give the decimal version or give the simplified radical form. That is the end of the Pythagorean Theorem lesson. Make sure to ask any questions that you might have, because I know some of these things that you learned today might have been a little bit confusing.